I'm here to show you how to start this activity because it's challenging. The goal of this activity is to take functions and non-functions, such as this circle or this ellipse, and write equations so that we can trace parts of this Mount Hood picture on slide 4. You don't have to trace the entire thing, but you're trying to figure out ways to like go over parts of this image using equations because that's what you're going to do in for your coloring book. And we want to have some practice. So the goal is to try to do at least one linear, one quadratic, one cubic. So a linear, a quadratic, a cubic, a square root, and an absolute value. And to see what those equations look like, you could go to slide 2 and actually look at what they look like in their forms. And then to know what their equations should be, go to slide 3 and look at their baseline equations here. I'm going to start by copying and pasting a linear equation. So copy and paste. And there are elements of guess and check to this, and there are elements of using like informed reasoning. So what I want to do here is look at this graph and try to graph slash picture and try to decide where I think something is showing up. And when I say something, I mean where I think a straight line is showing up, because that is what I'm looking at right now with linear. So right here, this yellow like divider on the street looks pretty straight to me. And so I'm tracing it here. I want to decide what my slope is on here, and it kind of looks like I'm going up to right 1, up to right 1, up to right 1. If I could extrapolate this line, it might hit around here at 3. So I'm going to make a good educated guess as to my equation up here, and I'm going to make my slope 2 over 1, which is just 2/1. I'm going to make my b, my y-intercept, a 3. And you see how that red line just popped up right over the top of the graph I had going? That shows that I was pretty close. Really close, actually. How exciting. So what I could do is I could lower this y-intercept a hair by maybe a 2.5. And this is now going over this yellow pretty well. What I want to do is to match the graph and not have this line go through Mount Hood. So I have to start restricting my domain. And here's how you do that. You want to look at where you want your graph to start and stop, and then decide if it is on the X or Y axis that you're referencing. So I want to stop right here, and I want to stop right here. I need to look at where those points would be. I'm trying to show you where that would be, and I'm looking up here at the x-axis right there. So that is the point -8, 0. And this right here where I want to stop it is around, I don't know, -3.5, 0, about. So I'm going to take that information to restrict my domain. And that sounds like a crazy word. All I mean by that is shift bracket right underneath like the plus sign area. And I need to limit my graph so that it only exists when x is between this -8 and this -3.5. So I will write -8 is less than my x, which is less than my -3.5. And you'll see that we just bound that and it stopped exactly where I wanted it to. And now I can kind of erase this so that you can see around. And I have created a red linear line through that, I don't know, street. One thing that's really cool about this is that you can go up to this wheel, it says edit list, and you can click the color of line that showed up, and you can make it darker, you can make it thicker, you can change the color. So I'm gonna make it orange, and I'm gonna make it really, really thick by making this a 10 here. See how thick that is? Now you can more accurately see what I just did, and it's right here. I'm gonna start a quadratic with you, and then I want you guys to try to play around and do what you can. So I'm gonna go back here. I prefer vertex form right now because I'm going to look at the graph and try to find a vertex. So I'm going to copy the quadratic equation. I'm going to paste my quadratic equation once my computer loads. And I'm going to look at the graph and decide if I can find a place that looks like a parabola anywhere. I am going to put a parabola Where would be a fun spot? Might be weird, but I'm gonna put one because I want to. Right here over this tree. I'm gonna make a little parabola right there. To make a parabola there with vertex form, I have to think about what that top center point is as a coordinate. That point is approximately 0.5 comma -1, approximately. So I'm going to start my equation by putting in a 0.5 and a -1 for my h and k, since I know that that's what does my movement horizontally and vertically. And then I know that this has to go upside down because my tree goes bloop. So I have to have a negative in front of my a value. So I'm going to subtract the a and write a -1. And now all of a sudden you can see that I have a vertex equation pretty much right exactly where I wanted it because I was able to use the graph to make that happen. And now I need to change my a value to make it much, much, much skinnier, which means that the number has to be much larger in the negatives direction. So I'm going to try 7. That's not terrible. 6. Being who I am right now, I'm going to change this 0.5 to a 0.4. Okay, this looks good. I'm feeling positively. I'm going to go into my settings. I'm going to click my green, and I'm going to make it thicker again so that I can actually see where that's showing up. And then lastly, I'm going to restrict, this time I'm going to restrict the range. And that means that I'm going to cut down what the y is. And I'm doing that because I want this to abruptly stop right here and not continue. I want my tree to stop. And that means I'm getting rid of all of this like vertical stuff. So the y value here is approximately -3. So for this, I'm going to put brackets, shift bracket, y has to be larger than -3. And that cuts off the bottom of my function so that my little tree just has this cute little top, boop, 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 boop. And it was done with using like, a slight guess and check and tweaking, but really looking where that vertex was. So good luck. This is a really fun, hard challenge. Ask for help, work with each other. You got it.